Hello viewers, here we are. This is the third video from this series. Hope you enjoyed watching the first two videos and found it informative. If you have not subscribed to the channel, please do subscribe to it so that you get updates on the new videos as well as keep your post notifications on. This series is composed of multiple videos. First video describes how ML is powering smartphone applications and chatbots. There is a video showing use of machine learning for social monitoring and predictions. In another video, you will be happy to know how machine learning is helping speed up the research on treatment and vaccines. There is a special video that shows contribution of ML to medical equipments like X-ray scanners, etc. I have also mentioned drones and robots in that video. This third video is dedicated to a very important topic. It shows how scientists and researchers benefit because of ML. It also shows examples of how vaccine making companies are benefiting because of machine learning. Traditional methods of drug discovery or drug development were consuming a lot of time and cost. There were possibilities of downstream failure after you have spent a lot of effort and after you have spent a lot of money on a particular experiment. Machine learning solves both these problems because there are computational models, the cost attached is smaller, as well as there is a faster delivery of options, faster delivery of research. In addition to that, machine learning can process huge amount of data sets even if they are unstructured in manner. The data and the information which was difficult to comprehend to human mind, machine learning can very easily comprehend and analyze that huge amount of data sets. In addition to that, machine learning can create more options, can design diverse molecular structures. So, a big round of applause to machine learning. Vaccine making companies were also benefiting because of machine learning. As you can see, the machine learning model uses simplified chemical sequences instead of using complex 2D, 3D molecular structures. That helps in analyzing suitable raw material, be it organic or synthetic. It allows quicker examination of protein structure. It allows more accurate prediction of impact on protein structure on coronavirus. Because machine learning models are computational in nature, they can eliminate futile alternatives. In this first example, a startup called EVQLV has achieved this excellent feat. Andrew Sads, the CEO, claims that conducting antibody discovery in a lab can take multiple years, average 5 years, and almost $500 million to find high affinity and optimize antibodies. What our algorithms do is reduce the likelihood of drug discovery failure in the lab, Sat says. And how do they do it? It's of course a multi-step process which starts with training your machines to find patterns in a massive database of genes and proteins. Then as a second step, they generate smart therapeutic candidates using machine learning. In third step, computationally screening and optimizing of these therapeutics for liabilities or stability or multiple other parameters can be achieved. And as a fourth step, final step, they generate thousands of 3D models, assess the binding affinity and solubility of these genes. By completing these steps, EVQLV technology has resulted in a library of multiple optimized leads with the highest likelihood of advancing to clinical studies. In this second example, we see in silico medicine has used even more advanced machine learning technique called generative adversarial networks, GAN. It favors molecules scoring high for drug-like properties and for being chemically active, whereas the molecules which are unlikely to ever work as drugs are completely thrown out or discarded. In general, molecular synthesis and testing is a very slow process. Here you can see that traditional hit lead for generation is about 2 to 3 years, whereas the new approach from in silico has achieved this in less than 46 days. What a remarkable achievement. They have used the AI's help to bring down the synthesis time and creating more options to designing diverse molecular structure. Existing algorithm for RNA secondary structure prediction had a large runtime. It was scaling cubically with the RNA length. And because genomes like coronavirus family had large RNA lengths, it was taking like 55 minutes. So Baidu's AI based to linear fold reduces this prediction time from 55 minutes to just 27 seconds. As you can see, linear fold is the first RNA folding algorithm to achieve linear runtime. Indian ICMR has helped their frontline officers as well as data entry operators by the help of IBM Watson Assistant. The queries from the frontline officers as well as data entry operators are automatically answered by Watson Assistant, as well as all the data, the latest information, policy guidelines are fetched and passed on by IBM Watson Assistant to these operators. What type of queries they can ask? Say nature and process of data to be captured by test labs, the reference to latest guidance and policies, how to record inventory of test kits and reagents, as well as reporting process to government agencies. Another example is Ictos's deep learning model, which is generative in nature. It designs virtual novel molecule. The system can design, make and test new drug-like molecule in just 1 to 2 weeks. Ictos has recently released 2 AI-based software platforms to accelerate drug discovery. Now let's quickly look at some examples of how vaccine manufacturing industry is being helped by machine learning. Google's DeepMind, which is using AlphaFold system, has announced that they are releasing structured predictions of several proteins that can promote research into ongoing research around COVID-19. Similarly, Deergen's deep learning model that they have developed called MT-DTI can identify compounds that can tackle the virus. Since we are on the topic of vaccine, it's good to mention these 2 research papers. In the first research paper, machine learning model is used to predict the possible inhibitory synthetic antibody for corona. In the second paper, machine learning has been used to predict the composition of protein corona. Alright, so this brings us to the end of third video from this series, where we saw how machine learning is helping speeding up research on vaccine and treatment. Isn't it a good news? Keep watching, do subscribe to the channel for upcoming videos, and also to get access to the older videos, do keep your post notification on. Stay healthy, stay fit, and enjoy your day.